All right, this is questions 9 through 12, I believe. I think this thing is wrong, but we have Japanese government bonds that have a yield to maturity, a maturity in less than 5 years, and they have negative yields. So we have one bond in particular that has 2 years when it's issued. The coupon rate is 2%. It pays semi-annual coupons. Yield to maturity is minus 1%. So the question in the first one is, what is the price that you would pay for this bond? All right, so let me make this a little bigger. The coupon rate is 2%. The face value is 1,000. So that means the coupon is going to be 1,000 times 2% divided by 2 because it's semi-annual coupons. And it's a 2-year bond. I'm going to draw the timeline. I don't know that we really need it, but let's do it anyway. 10. Oops. I got it. Let's lock that. And here we'll get $1,000. So the question is, if the yield to maturity is minus 1%, what is the price? Well, so the effective semi-annual rate is going to be that divided by 2. There's a lot of ways you can do this, but let's just do price equals PV, rate, number of periods is 4, payment is 10, face value is 1,000. 1,060, which should be answer C. And I have pulled up the answers, and we also get 1,060. Okay, let's go back to the problems. 1 year has passed. You would like to sell your bond today. Assuming that the next coupon is paid tomorrow and yields haven't changed, what is the price? So we're standing here, but we also need to include this cash flow. So I'm just going to move all this down. And this is now 0, 1, and 2. Again, a lot of ways to do this, but the easiest way would be, this is a times 0 cash flow, so I don't have to discount it. I can take the PV, that's the rate, number of periods is 2, payment is 10, face value is 1,000, close the parentheses, I get minus 1,020. I'm sorry, it's, I need to make sure, oops, yeah. And let me just put a minus here so that we're consistent. Okay, so this highlights a big problem in this formula, which is PV returns a negative number. So if you use the PV formula, you have to use a negative here, otherwise you'll get the wrong answer. But basically $10 minus the negative PV is plus a PV, and that gives us 1040. Which is answer D, and let's just check that, 1040.23. Okay, next one. Let's look at the actual question. What would your answer be if bond yields decline to minus 2%? Well, it'd be 1050.61, which would be more than 1040. Let's check our answer. 1050.61. Okay, last question. 6 more months have passed. That is, your bond matures in 6 months. A coupon was paid yesterday. The bond is currently trading at 1020. What is the yield to maturity? Okay, so let's scroll down again. And 0, 1. All we have here is a payment of 1010 and a price of 1020. I'm going to guess at an interest rate, and I'm going to take the PV. The NPV is this. I'm going to use GoalSeek to set this value equal to 0 by changing the interest rate. Whoops. cell must contain a value. Oh, it's because I didn't put this in, 0.025. You have to actually hard code it. If it's a formula, it won't work. Do that again. So this is the effective semi-annual rate. To get the yield to maturity, I'm going to do that times 2. To get the annual rate, I'm going to do 1 plus that to the power of 2 minus 1. It didn't ask for both of those, but I went ahead and gave them to you. So this should be minus 1.96, which is between these two. And let's just make sure minus 1.96 is the yield to maturity. One last thing, the annual rate. Notice that I squared it and then subtracted 1 in order to get that answer. And you have to do 1 plus or else you'll end up with the wrong solution. And they will obviously be different because this includes compounding. So anyway, hope that helps.